Good morning, girls. Coming to the standard error problems in Unit 4 of your research methodology, that is calculations of standard errors. In the second problem, it was given that a 6-phased dice, I think you will be knowing, a 6-phased in dice will have 1, 2, 3, 4, 5, 6 digits. When you throw a 6-phased dice for 324 times, he was asked that odd points appeared for 180 times. Would you say that the dice is fair at 5% level of significance? This is the question asked. Before we go for the explanation, let me tell you, when you throw a 6-phased dice for 324 times, he is asking that what is the chance of getting odd points and even points. So here a 6-phased dice is thrown for these many. How many times let it be? That's not an issue. Here when you throw a 6-phased dice, getting odd is equal chance of getting an even point. Means how many times you will be getting 1, 3, 5 digits equal to getting off 2, 4, 6 points also. So here also when you throw a 6-phased dice for 324 times, you will be getting, the chances are there for getting odd faces or even faces. Here he has asked for odd faces, it is 162 times. So, but here appears that he has got odd points for 180 times. That's the reason he is asking you that whether this hypothesis is correct or not. So now your n is equal to 324. Always do remember, girls, whenever you are calculating any problem in statistics or mathematics, before your calculation starts, you have to write the given information and write the formula. Standard error is equal to square root of NPQ. So here n is equal to number of items and number of times your dice or a particular variable was executed. That is n is equal to 324 times. P is equal to half. Means getting a chance of getting odd point or even point are equal. 50% of chances are there. So half, Q is equal to half. If you interpret these values in the formula, that is 324 into half, that comes to square root of 81, which is equal to 9. So therefore here your standard error is 9, and the difference between the optimal getting of odd points here is, in a particular dice when he has given, he has got 180 times odd points, where as per our hypothesis it should be 162 times minimum. So he has got 18 times extra. So 18 by 9, that is equal to 2. Now what can be your probable conclusion? Actually I said 1.96 is the parameter, where our hypothesis says that if the dice difference means between difference got and standard error is 1.96 up to, your hypothesis stands unbiased. So here, since the difference is more than 1.96, means 2 is more than 1.96. So more than 5% level of significance, which is 1.96, the hypothesis is rejected. Because more than 1.96 times if a dice particular significance is observed, this particular hypothesis will be rejected. This is what our observation says. Why we are rejecting this? When in the first point problem we got below 1.96, we said yes, the hypothesis can be agreed. This particular problem number 2 we are rejecting because 1.96 is our standard level of standard error, where we got the answer here is 2. So your conclusion must be this particular hypothesis is straight away rejected because it is more than 1.96 of our parameter. If you see the third problem also, in the third problem in standard errors, he said that in a sample of 500 people from village, means your small n is equal to 500. Out of a village from Rajasthan, where 500 people were taken as sample, 280 were found to be rice eating, where others are wheat eaters. Means here also, as a coin have two faces, here also is giving a calculation of the population between rice eaters and wheat eaters. So how many people will be getting rice eaters? Means your P is equal to half, because minimum time out of 500, 250 should eat rice or wheat. So again your P is equal to half and Q is equal to 1 by 2. The expected frequency of rice eating is equal to, how you will be calculating, out of the total number of population 500 divided by 2. What is this 2? Rice eaters or wheat eaters. So minimum of 250 each, means minimum 250 people should eat rice or minimum 250 people should eat wheat. Now, standard error is equal to formula square root of NPQ. So, that comes to N is equal to 500, P is equal to half and Q is equal to 1 by 2. Always do remember, you have to write the given information, write the formula, then interpretation. So, that comes to square root of 500 into half. That comes to square root of 125, that is 11.18. Now, this is time for us to find out the difference between the expected and observed. What did he say in the problem? 280 people are found rice eaters. Actually, as per our observation, when there are two types of phases like rice eaters and wheat eaters, minimum you must get 250 each out of the given observations. So, 280 he said are rice eaters. Actually, it should be 250. So, the difference is 30 people eating rice over here. Again, when we calculate difference by standard error, difference is 280 minus 250, that is 30 divided by your standard error 11.18. That comes to 2.68, which is more and more to your particular standard error parameter, which is 1.96, 5% of your standard error. So, the conclusion must be, since the difference is more than, means more and more 2.68 than 1.96, we cannot assume that both food eating qualities of people of Rajasthan, that is rice eaters and wheat eaters, are equally popular. So, this hypothesis is tested negative because it is ill-used, because we can't assume it is more compared to problem number 1. Problem number 2, here you got 2, which is just above 1.96. Even then this hypothesis was rejected straight away. Now your hypothesis in the problem number 3 is 2.68, which is more compared to your standard parameters. So straight away this hypothesis he asked you that can we assume both. The question asked for you in problem number 3 is, can we assume the both food articles of quality of population? Now your answer must be no, we cannot assume, because the standard error difference is more than 1.96, which is 2.68. So your conclusion must be, hence we cannot assume the food eating habits of people of Rajasthan basing on this hypothesis.